All right, so now we're gonna look at some integrals where we're gonna actually need to use long division before we integrate. And that's simply because the integral won't be, super simple to, find the antiderivative in the current form like this. Um, so always, again, with integrals, be prepared to be, clever and think outside the box and learn techniques and strategies because, integrals are not like derivatives. You don't have formulas to just find a way to integrate every integral. But again, there are techniques. So let's go through a couple of them. So here we have the integral of x squared plus x plus 1 over x squared plus 1. We can't use u substitution, like it won't work. Like we can try making u the top or making u the bottom. It won't work out. Now, what we can do though, man, there's a dx missing. What typo? Let me put that dx there, actually. There we go. Okay, so what we can do instead is rewrite this in a different form. It's going to be the same value, same expression in that, but just appearing, it'll just appear different. So let's go back to our pre-calc days where we have long division of polynomials. We got the x squared plus x plus 1 inside the house and the x squared plus 1 on the outside. Start dividing. So 1 times x squared will be x squared. And 1 times 1 will be 1. And then we go ahead, x squared minus x squared, that goes away. X plus 1 minus 1. So we'll just have x here. I technically should put the 1 over here on top of the 1 if you want to be teach a good habit. So put that 1 there. So we have an x now. So we can't divide that, neatly, so to speak. So what we have now, remember how we would go about this in your pre-cal, maybe algebra 2 days, we would leave this as 1 plus x over x squared plus 1. What's going on with this pencil? Okay, so instead of this, we're going to rewrite the integral as simply 1 plus x over x squared plus 1. So this is equivalent to this, but this is actually possible to integrate by using u substitution. And we're just going to use it for this part. So we can, technically, you can separate this, write this as 2 integrals. So you can rewrite this as is 1 dx plus integral of x over x squared plus 1 dx. That way we don't confuse the u with the 1 and all that. So we're going to use u substitution here. And what we're going to do there is we're going to make u equal to x squared plus 1. And then du will be 2x dx. And we divide by 2 because we just have x dx. And we go 1/2 du equals dx. And then we can rewrite this as, let's go up here so we can make sure we don't run out of space. We write this as an integral of 1 dx plus integral of 1/2 du over u. So 1/2 times 1 over u du. And then this is simple. Well, should be simple. This is just going to be x. This will just be 1/2 times the natural log of the absolute value of u. Let's make sure we add our constant to the whole expression. And to rewrite then rewrite this in terms of x. So replace the u with the x squared plus 1. So we'll get x plus 1/2 times the natural log of x squared plus 1 plus c. And that's your answer. All right, let's look at another one now. Here, we got the integral of 2x over x plus 1 squared. And we don't technically have to use, you know, the same technique that we did here. We don't have to use long division, but this is going to be one where we have to be clever with our u substitution. So let's go through it. So what we're going to do is, I'm going to make u equal to x plus 1. And du will then be simply dx. And we don't have, we don't have that 2x dx. We just have that dx. But let's just go for it for now. Let's trust me on this, because what we can do is we need to find a way to write that x in terms of u. And if you look here, all we have to do is solve this for u. I'm sorry, solve this for x. What we can do is take away 1 from each side, because u minus 1 is then equal to x. So if u minus 1 is equal to x, we can then replace that x on top with the u minus 1, and then replace the x plus 1 down here with just u. And then that 2, you can put 2x, but that 2 can just factor out. It doesn't actually be, it's not really even an issue. But then this will just become, let's actually take that 2 out, 2 times, on top we got u minus 1, and in the denominator we have u squared du. And then from here we can integrate much easier, but let's break this up. It's easier to, integrate. 2 times the integral of, so u over u squared minus 1 over u squared du. So one more step. U over u squared is simply just 1 over u. And this is just going to stay as minus 1 over u squared du. And then here, we can just integrate this easily. So let's go way over here so we can go straight across. So remember, this is 2 times integral of 1 over u minus, and this is the same as u to the negative 2. All that is being multiplied by du. So when we integrate this, this just becomes 2 times the natural log of the absolute value of u for that first part. Not plus, minus u to the negative 1 over negative 1. Let's rewrite this as a plus of 2 natural log of the absolute value of u plus 1 over u, or plus 2 times 1 over u, or just plus 2 over u. You got to distribute that 2 to both of them. And then we just replace the u with our x plus 1. And so we'll get 2 times the natural log of the absolute value of x plus 1 plus 2 over x plus 1. Plus our constant c, of course. Let's not forget that guy. And there you go. That's all there is to it.